this is an iHeart podcast. Guaranteed human.
With no fees or minimums on checking accounts, it's no wonder the Capital One bank guy is so passionate about banking with Capital One. If he were here, he wouldn't just tell you about no fees or minimums. He'd also talk about how most Capital One cafes are open 7 days a week to assist with your banking needs. Yep, even on weekends. It's pretty much all he talks about, in a good way. What's in your wallet? Terms apply. See CapitalOne.com/bank. Capital One, N.A., member FDIC.
Hi, Kyle. Could you draw up a quick document with the basic business plan, just one page, as a Google Doc, and send me the link? Thanks.
Hey, just finished drawing up that quick one-page business plan for you. Here's the link.
But there was no link. There was no business plan. I hadn't programmed Kyle to be able to do that yet. I'm Evan Ratliff, here with a story of entrepreneurship in the AI age. Listen as I attempt to build a real startup run by fake people. Check out the second season of my podcast, Shell Game, on the iHeartRadio app or wherever you get your podcasts.
Welcome to Stuff You Should Know from HowStuffWorks.com.
Hey, and welcome to the podcast. I'm Josh Clark. There's Charles W. Chuck Bryant. You put the two of us together in front of a couple of microphones in an alarmingly red room. You have Stuff You Should Know, the podcast.
That's right.
The podcast.
The one and only.
Yes.
Not Catholic Stuff You Should Know.
Is it still around?
I don't know.
They need to do penance for that.
There's a guy on YouTube, too, that has a little video series called Stuff You Should Know.
That's copyright infringement.
I know. I think he's being dealt with, actually.
Is that right? That's hilarious.
Yeah.
That's what happens.
And it's not about stuff you should know. I mean, it's really... I don't know why he called it that. It's weird.
What's it about?
Well, just go watch it.
Oh, well.
Everybody out there, go watch it.
Right.
Yeah.
We're just going to boost him to fame, huh?
Exactly.
Chuck.
Yes.
Have you ever seen a black hole?
No.
No, you haven't. And you know why?
Because no one has.
They're invisible.
Yeah.
As a matter of fact, we can't even say 100% that they're real if you're an empiricist. And empiricism, if you forgot your philosophy 101,
I have,
is the idea that nothing exists unless you can detect it with your senses.
Okay.
One or all of the five senses.
Do you know who championed that? I'm just asking.
Let's say Bacon.
Okay. I thought you were going to say Descartes, but...
I don't think so.
Okay.
No, Descartes was more into himself.
Yeah, sure.
He talked a lot about the I.
Yeah.
Yeah. I'm going to say Sir Francis Bacon.
All right.
Okay?
Great.
I'm probably totally wrong, but...
I love bacon.
Empirically speaking, black holes don't exist because we can't detect them. We can't hear them. Although I have heard that they do make a sound.
Yeah, and I have Morgan Freeman said that we can probably hear them before we can see them.
Okay. The reason we can't see them, so let's just say if you are hard of hearing or deaf.
Okay.
And you can't taste.
Yeah.
And you can't touch. You have no sensations. It's just your eyes that you rely on.
Yes.
Black holes will probably never exist to you.
Gotcha.
That's my intro.
That's good.
Thank you.
This one melted my brain a little, have to admit.
I was expecting a brain melt, but I thought Freud and Rich, we've never figured out how to pronounce his name.
Let's go with Rich.
The only writer at How Stuff Works with a PhD.
That's
so
right.
They toss him ones like how black holes work. I thought he did a decent job.
I think it's high time we get our honorary PhD.
Where would you want yours from?
I don't know. Someplace, I don't know. Maybe Georgia.
Okay.
Yeah, why not?
I'd take a doctorate from Georgia.
Yeah.
That I didn't have to lift a finger
Sure.
for. Okay. Well, we just put the call out.
My dad got a doctorate from Georgia.
Yeah, but he got a real one.
Yeah, sure. He had to write the whole thesis and all that stuff.
Do you ever call him doctor?
No, but that's what he went by the whole time, Dr. Bryant.
If you got an honorary doctorate, you could do that whole Spies Like Us thing with your dad.
Doctor?
Yeah.
Yeah.
We're really stalling on this one.
I know.
We don't want to talk about black holes. All right, I'm going to kick it all off. All right. So, black holes, we don't know that they exist for certain. Although, yes, we do. You can't see them, I guess is ultimately what I'm saying. But there was a real lag in between the time that they were predicted to exist.
Yeah.
before we started figuring out how to detect them, and we detect them indirectly.
Sure.
But a lot of people say Einstein was the first one to predict black holes. Not true.
Yeah, this blew me away.
Oh, yeah?
This dude,
Yeah.
1795.
Pretty smart. Think about it.
What's his name? Pierre Simon Laplace.
Mm-hmm.
And he used Newton's theory of gravity, and he calculated, if there's an object compressed small enough,
Right.
The escape velocity of that object would be faster than the speed of light, and he was like right on the money.
Yeah, which means that nothing can escape this, including light.
Yeah,
Because if light can't escape, it's the fastest thing around.
that's right.
Then nothing can.
Yeah, I guess we should just say simply straight up, first of all.
Yeah.
We still haven't even said what it is.
Yeah, we should probably do
It
that.
is what remains after a former star collapses upon itself,
Right. After Gordon Webb collapses upon himself.
either by supernova, which is a little more explosive, I understand,
It's dramatic.
or I just learned this term, an unnova. Have you heard of that?
No, I haven't.
I think that's newer on the scene, and that is a little more anticlimactic, and that's when a star will just sort of disappear. It's not a big explosion; it just kind of shrinks and collapses.
It's like the Greta Garbo of black holes.
Yeah, exactly.
Yeah.
So, or an unnova.
I've not heard of that one.
I watched Through the Wormhole today, and there was a guy just going on and on about the unnovas.
Yeah.
Yeah.
He's like, seriously, they're so understated. It's
Yeah.
awesome. Okay, so let's just give a quick primer of what a star is. A star is essentially a big fusion reactor.
Yeah.
Right? So there's nuclear explosion after nuclear explosion. It's constant, and they're massive, and they want to blow the star, which is a ball of gas, outward. But you have another force called gravity,
Yeah.
which is trying to draw the star inward toward its center. So you have this interplay, this push and pull between nuclear explosion and gravity, and that defines the star. Right?
Yeah.
The equilibrium between the two.
Yeah, and as I understand it, as they have these reactions, they're actually burning up these gases in like a specific order even until eventually there is none left. Is that right?
Right, yeah. Gravity's always going to win out because the star's going to spend its fuel ultimately, right?
Okay.
So when the star spends its fuel, gravity's like, haha, I got the better of you, and I'm going to start pulling in like I've always wanted to.
Yes.
And it compresses everything. And then in the case of a supernova, the supernova happens, that explosion, right,
Yeah, it sends stuff all out, all over the place, and then what's left?
is a core.
Yeah.
But it's a super compressed core,
Yeah,
which
it's
is
dense,
fairly small.
The most dense thing you can imagine.
Right. So our Earth has a gravitational field. It's a pretty massive body. Comparatively speaking, it's a speck. But to you and me, it's pretty big.
Yeah, sure.
And it's big enough so that the gravitational field prevents it from being sucked inward.
Yeah.
Right? But if the Earth were smaller, the gravitational field would get stronger and stronger because the more dense something is and the smaller its radius is, I believe is how they put it, astrophysically speaking, the stronger the force of gravity acting on that. So the gravitational field around that small object, like the core of a dead star,
Right.
is incredibly strong, right?
Yes.
So you got that core and this gravitational field acting on it, and gravity just keeps pressing and pressing and pressing until the thing actually sinks into the fabric of time and space. And my friend, you have a black hole now.
Yeah.
You have a hole in the fabric of time and space.
Yeah, you can't see into it. You can't send anything into it to report back.
Well, yeah, that's the caveat. You can send whatever you want into it,
That's
but
true.
it ain't coming back.
It ain't coming back.
No.
It will swallow anything that crosses the event horizon, which is like the mouth.
Yeah, it's like the rim, right?
Sure.
Okay.
But it doesn't just like this thing I read, and we need to give a shout out to Hubblesite.org.
Hubblesite.org is
A lot of
awesome.
good info there.
They have this great interactive thing on black holes. It's just really
I
extensive.
did that where you fly through space.
Yeah, it's very
It
cool.
was pretty cool. What's important to point out, because I thought it was just like this vacuum that just sucked everything inside of it and like killed it.
Yeah, it ejects stuff even.
Well, it ejects stuff, but it also doesn't suck anything into itself any more so than anything else in space with similar mass.
Yeah,
Like
you
the
think
sun
it's a
would-
vacuum cleaner, right?
Yeah, exactly. Like if we weren't going so fast around the sun, we could potentially be pulled into the sun, but because we're going around at I think 67,000 miles per hour, it prevents it from happening.
Right. Okay.
And theoretically, if you could go super, super fast around in an orbit around a black hole, you wouldn't get sucked in either. But you'd have to be in a perfect orbit.
Okay.
If you're off at all, then bye-bye.
Okay, so you mentioned the event horizon, right?
Yeah.
That core, that super compressed core, is called the singularity.
Yeah, we don't know a lot about that.
And a black hole has a lot of really cool, quirky aspects to it. Number one thing I learned about this that I didn't realize is that black holes move around space.
Yeah.
So you have a hole in space, the fabric of space and time, because time and space are totally intertwined. They can't be separated.
Yeah.
That's moving around, right?
And there could be lots of them, right?
So, yeah, depending on the kind.
Right.
There's probably tens of millions of ones called stellar black holes.
Yes.
Which are about anywhere between 10 to 24 times the mass of our sun. And then there's supermassive black holes, which are tens of millions to billions of times more massive than our sun. And
Yes.
they think that there may be one of those at the center of every galaxy.
Yeah, and at the very least at the center of the Milky Way.
Right. So
Yes.
the other quirky part, this is my favorite thing about black holes, is so gravity, if it's strong enough, it has the capability of bending space. It pulls on space.
Yeah. Space-time?
Yes, because space and time are intertwined, that means it also pulls on time. So if you get close to a black hole, and I think we talked about this a little bit in the time travel episode, as you get closer to the event horizon, the drag on time will actually slow time for you relative to, say, the people back here on Earth.
Right.
Because at the event horizon, the reason they call it an event horizon is an event is a point in space-time. And as you get closer to the event horizons, time slows until you hit the event horizon and time stands still. You're going faster than the speed of light.
It's
and once
crazy.
you pass that, there's time just stops. That's a pretty quirky characteristic.
I think quirky is a great word for it.
Yeah.
The event horizon has a radius called the Schwarzschild radius. Sorry about that. And it's named for Carl Schwarzschild, and he was one of the early leading theorists on black holes.
Yeah.
And I think the radius, I believe, where do I have that note? If the Earth were to become a black hole, I think the radius is the size of a marble. That's what you'd have to shrink the Earth down to.
That's awesome.
Yeah. Pretty cool and very small.
It's mind-blowing.
It is mind-blowing. And I think the supermassive black holes, like the supernovas, have only, I think they happen once or twice per century. So we haven't observed one of these because it's too far away.
Oh, yeah?
And it's too intermittent.
Huh.
But I think they're on the lookout, and the next time there is one, hopefully it's within the range that we can see or hear. And the dude on Through the Wormhole was like, we wouldn't sleep for weeks if that happened. We'd be running so many tests.
Oh, gotcha.
Trying to measure and, see how big it was and how far away it is. And so it's a bit of a quandary.
Do you think it will happen anytime soon?
I don't know. I don't know when the last one was.
So you just mentioned the supermassive black hole, and they think that there's one at the center of every galaxy, right?
Yeah.
But there's kind of a mystery. If black holes aren't mysterious enough, there's a mystery to why there's such a huge difference in the two sizes. The stellar black hole, which is 10 to 24 times our sun.
Right.
Which, by the way, our sun will never become a black hole on its own. It's too small.
Yeah.
That guy, Simon Pierre Laplace, or Pierre Simon Laplace, he calculated that it has to be 3 times the mass of our sun. So our sun is a third of the mass needed,
okay.
Right?
Gotcha.
So it will never become a black hole. But it could become a black hole if it becomes a neutron star, or even as a star, if it collides with another star, it can form a black hole. It can be sucked up by a black hole to make an even bigger black hole. And they think perhaps, or I suspect this is the way that they're headed, they think that a supermassive black hole is just a bunch of black holes pushed together.
Yeah, because I did read if they collide, they potentially would just join forces.
Yeah, and they think also that stars can collide and create bigger stars and bigger stars and bigger stars.
Right.
And then when those die, they could on their own form a supermassive black hole. But if it's at the center of a galaxy, probably what's going on is like if you have a sheet and you put a baseball in the middle. Remember we were talking about wormholes?
Uh-huh.
It kind of bends the sheet. So if you drop a marble on the sheet, it's going to go toward the center.
Right.
So what I think is going on is that there's supermassive black holes at the center of a galaxy, and just eventually everything is moving toward that to form a huge black hole.
Really?
That's what I think's happening.
Wow. So we're all doomed?
Yeah, but not in our lifetime.
Okay.
Yeah.
Well, who cares about our children and their children?
Yeah. I can't even conceive of how far down that is.
Hi, Kyle. Could you draw up a quick document with the basic business plan, just one page, as a Google Doc, and send me the link? Thanks.
Hey, just finished drawing up that quick one-page business plan for you. Here's the link.
But there was no link. There was no business plan. It's not his fault. I hadn't programmed Kyle to be able to do that yet. My name is Evan Ratliff. I decided to create Kyle, my AI co-founder, after hearing a lot of stuff like this from OpenAI CEO Sam Altman.
There's this betting pool for the first year that there's a one-person billion-dollar company, which would have been like unimaginable without AI, and now will happen.
I got to thinking, could I be that one person? I'd made AI agents before for my award-winning podcast, Shell Game. This season on Shell Game, I'm trying to build a real company with a real product run by fake people.
Oh, hey, Evan. Good to have you join us. I found some really interesting data on adoption rates for AI agents in small to medium businesses.
Listen to Shell Game on the iHeartRadio app or wherever you get your podcasts.
The moments that shape us often begin with a simple question. What do I want my life to look like now? I'm Dr. Joy Harden Bradford, and on Therapy for Black Girls, we create space for honest conversations about identity, relationships, mental health, and the choices that help us grow. As cybersecurity expert Camille Stewart-Gloucester reminds us,
we are in a divisive time where our comments are weaponized against us. And so what we find is a lot of Black women are standing up and speaking out because they feel the brunt of the pain.
Each week we explore the tools and insights that help you move with purpose, whether you're navigating something new or returning to yourself. If you're ready for thoughtful guidance and grounded support, this is the place for you. Listen to Therapy for Black Girls on the iHeartRadio app, Apple Podcasts, or wherever you get your podcasts.
Should we talk about the different two different types?
Mm-hmm.
The Schwarzschild non-rotating type and the Kerr or Kerr-Newman rotating type. It's pretty simple. If the star was rotating before it collapsed upon itself, it will continue to rotate afterward.
Right.
For, I guess, as long as it's around. Is that right?
Yeah, it's the angular conservation of angular momentum.
Yeah.
Yeah.
Not
Where,
bad.
like, if something's spinning, why would it stop, I think is how it's put.
Like an ice skater.
Pretty much.
And the Kerr black hole is a little more complex. It has the singularity, which we've talked about, the event horizon, which we've talked about, which you don't want to go near.
No.
Did you see that movie?
I love that movie.
Oh, yeah?
It's one of my favorite horror movies.
I need to go back and rewatch it.
You should.
Because I remember liking it to a point and then not thinking it was so great.
No, you're thinking of...
Sunshine?
Yeah.
Okay.
Man, never has a movie spectacularly fallen apart.
Event Horizon was Sam Neill, right?
Yeah.
Okay. I
Which,
think I did
he's
like
a
that.
class act.
He is, isn't he?
Yeah.
And then there's the ergosphere, and that is the egg-shaped region. Basically, that's the spinning part because it's dragging space around it.
Right.
So it's going to have this shape. And then the static limit is the boundary between the ergosphere and what they call normal space.
Right. So there was something in here that, and I couldn't find this time, but before I found that a Kerr ring, right, the rotating black hole, doesn't have a singularity because the centrifugal force combats gravity enough so that the core can't be compressed enough to form a singularity.
Oh, really?
Which is the whole reason why they think that could potentially be used as a wormhole to travel through time.
A bridge, perhaps?
Right. Because with the singularity, you have spaghettification.
Right.
Which is a real word.
Yeah.
Right? Where as you get closer and closer to it, gravity just pulls you on an atomic and cellular level and stretches you into like this dead string version of yourself.
Linguini.
Right. But the centrifugal force prevents gravity from becoming that powerful around a Kerr ring, which supposedly you should be able to go through it.
Okay. Is that your theory?
No, I've seen it elsewhere. I'm just saying I don't know that a Kerr ring or a Kerr black hole has a singularity.
Right.
I dispute that.
Okay, I gotcha. And I think that the Schwarzschild black hole does not have the ergosphere or the static limit. Is that right?
Yeah, I don't think so.
Just the singularity in the event horizon.
Yeah, the Schwarzschild one is the one that you think of when you think of a black hole.
Oh, is it?
Uh-huh. It's just like a black hole. It's got a singularity. It's got the event horizon. Light
Boring.
can't escape.
Right.
Kerr ring, light can escape, and things can become ejected. And if you get up enough speed, you could pass by it, as long as you don't cross the event horizon.
Man, there's so many rules.
I know.
And plus, it's all theoretical, too.
Right.
Or not all theoretical, but a lot of it is.
Because if you could only see,
Yeah,
we don't even know that black holes exist.
but we do. But we can detect them in a few different ways. Is that right?
Yeah.
3 ways. Mass estimates. So basically, you can't necessarily measure a black hole, but you can study the thing swirling around it,
Right.
and get some idea from that about like how big it is.
Yeah, it's Kepler's third law of planetary motion, appropriately enough. And it says that the time of orbit squared equals the average orbital radius cubed, which somehow translates to mass. But basically, if you watch something spinning, first of all, you have to say, why is that thing orbiting something that we can't see?
Yeah. Why is it wobbling?
Right, if it's wobbling. And if you trace its orbit and take that to the second power, square it, if that equals the mass of 3 times or more of the sun, then you probably have a black hole. You probably detected a black hole that's in the vicinity of that thing that you're tracking.
So basically, this thing is acting like it's near a black hole, and there's no other reason that we can pinpoint.
Yeah.
So it must be a black hole.
Yes.
All right. Well, that's simple enough.
Yeah.
Gravity lens. Einstein predicted that you could bend space.
Yeah.
Pretty smart dude. And he actually confirmed this. Actually, did he confirm it?
No, he basically,
This was
with
later
his
on, right?
theory of general relativity and special relativity, he just made a bunch of predictions that,
And he's like, you guys go out and figure it out.
And everybody did, and
If I'm right.
he was proven right.
So it was confirmed during a solar eclipse. Star's position was measured before, during, and afterward, and the position shifted because light was bent by sun's gravity.
Yeah.
Pretty amazing.
It was like, here I am, here I am, here I am. And another effect that a black hole can have as far as light's concerned is it can concentrate light by bending it, by that gravitational lens. So a star can become brighter all of a sudden.
Right.
And when you can't see what's doing that, you must assume that a black hole passed in between your line of sight and that star.
Sort of like a eclipse.
Right.
All right. And then emitted radiation, this one makes a lot of sense because it emits X-rays because of the heat generated when something falls into the star. And you can actually measure and detect these X-rays.
Right.
So,
and not just X-rays,
that's a little more
gamma
concrete.
rays too, apparently.
Oh, really?
Yeah. But this stuff, it's called accretion, where if something's swirling around a black hole and it goes in, or it's sucked into the swirl around a black hole.
Right.
Toward the event horizon through gravity, that's called accretion. And what I don't understand, I didn't think black holes spit anything out. Like, I thought they were the cosmic vacuum cleaner, too.
Right.
But it turns out they can spit out matter, and when they do, they form these things called jets. So if you see a solar system or a galaxy, and there's a lot of matter flying out in these concentrated forms called jets, there's probably a black hole there.
All right. Well, I went to the Hubble site and picked out a few questions about black holes.
Okay.
That are, I think, help clear up a few things, at least it did for me. Do black holes live forever?
I'm going to say yes.
No. We used to think that, actually. So you were thinking with your 1973 brain.
Right.
Stephen Hawking came along in 1974 and showed that they actually evaporate over time really slowly and just sort of emit their energy back into the universe, which is kind of sweet.
I guess.
Yeah?
Yeah, but I don't understand how. like the core burns out or the core breaks up?
I don't know. He just said they slowly evaporate.
Okay.
And who am I to argue?
Right, exactly.
How large are they? The size of an event horizon is proportional to the mass of the black hole. And so they found them with event horizons from 6 miles to the size of our entire solar system. So
yeah,
big differences in size, like you were talking about.
Yeah, I can't remember the name of the galaxy, but there's a galaxy that's like the size of our solar system at the center, but it has a mass of like 1.2 billion times the size of our sun. So they're like, okay, there's probably a black hole there.
This is when my brain starts melting. It's like I can't even conceive this stuff.
I know. We're talking about like the layman's interpretation of, this stuff. Like, we're not even throwing numbers out there.
Yeah, I don't feel too bad because the more I researched it, the more I saw a lot of really smart people saying like, this is mind-blowing stuff.
Okay.
Yeah.
So
I'm not that big of a dummy. What types are there? I think we already said supermassive or stellar mass.
Yeah.
Can you safely orbit a black hole? You can if you, like I said.
I was going to say no.
If you get in the exact right circular orbit. But it's very unlikely that would happen.
But once you cross the event horizon, that's that. You're toast.
That's that. Toast.
Okay.
And then what is inside a black hole? Because we cannot glimpse inside of it. We don't know for sure. But they think that the singularity is, like, they think everything is piled up in the center.
Mm-hmm.
Like, just stacked up. Like, whatever it's sucking in is stacked up at the center. But to understand it fully, they're having to marry basically two different parts of science, which is quantum mechanics and gravity, and they've even named it quantum gravity. And they don't know how that stuff works, but they did name it.
Well, at least that's a step.
Yeah, and the Hubble site said it's one of, if not the most important unsolved problems in physics still. So.
Yeah, because there's like a hole in this fabric of space-time.
And Morgan Freeman thinks in the black hole could be the answers to everything.
I wonder.
Yeah, me too.
I've also wondered, like, if say the singularity is really just forming a tunnel, does it break through? Can you break through space-time? Or is it really just like a well? Because, a well doesn't go all the way through the Earth.
Morgan Freeman talked about a well. That's funny.
Well, I mean, but that's, I think, what it is. Because something has to hold the singularity in place, right? It's got to be butted up against something.
Yeah.
So I wonder if it's just pressed down to a degree that gravity can't push it any further, or is it something that's just like punched through? And we assume that the core is still there, but it's long gone.
Right.
It's in China.
Good question.
They'll answer it in 150 years.
I just read, our friend Joe Randazzo.
Yeah.
He recommended these books to us, time travel books.
Yeah.
I read one of them over the weekend, The Man Who Folded Himself.
Mm-hmm.
Highly recommend it.
Yeah.
Very trippy. Written in 1973. It's like one of those,
Mm-hmm.
And
is it fiction or nonfiction?
It's nonfiction. It's
it's
about a guy who gets a time belt from his uncle.
That's nonfiction?
What did I say it was?
Nonfiction?
No, it's fiction.
Okay. I was like,
did I say it was nonfiction?
Yeah, who is this man?
No, it's very much fiction. Science fiction. And he gets a time belt from his uncle that basically he subscribes, or the author ends up subscribing to the many worlds theory, because every time this guy time travels, he creates a different version of himself in a different world, but they meet up. So he ends up having a relationship with himself.
Really?
And then he ends up having a relationship with many of himself.
Like, has a relationship or makes relations?
He has sex with himself.
Wow.
And then he has an orgy with himself.
Wow.
And then...
That is so 1973.
Oh, it is, dude. When you're reading it, you're like, you get to see this guy. Like, he's from California,
it's
I'm
like
sure.
a Kinky Friedman book.
And then he eventually... there are female versions of himself created in these different realities, and he has a relationship and gets his female self pregnant and has a little boy who ends up becoming who he was, and he delivers the time belt to him at the end.
That's fantastic.
I guess I just ruined it.
Yeah, that's pretty much the book.
Yeah, it's well worth reading, though. I mean, it'll melt your brain.
I read
twice over.
Almost no fiction these days anyway, so thank you for that.
It's good.
You're like a walking Cliff's Notes.
And it's short, so like you could read it. I read it over the weekend when I was at the cabin, so it was nice.
Nice.
And The Hunger Games.
Did you read that, really?
Yeah, I read it in a day.
How was it?
It's those books like that it's like a popcorn movie,
Yeah.
It wasn't bad. It really moved along. And
Is
then
it
I
one
saw
of
the
those-
movie, and the movie stunk.
Does it have like 3-page chapters? Is it like one of those books?
No.
Oh, okay.
Yeah, I mean, it was fun.
Nobody writes
It's definitely not
chapters
high art
anymore.
or anything,
Yeah. I don't know anything about it.
It's the most dangerous game.
Oh, that's a good one.
I think
There's an RC plane outside?
it sounds like it.
There's a couple of them. I think
Man.
there's an RC
It's
dogfight
like
going
a
on.
drone outside our office.
Hi, Kyle. Could you draw up a quick document with the basic business plan, just one page, as a Google Doc, and send me the link? Thanks.
Hey, just finished drawing up that quick one-page business plan for you. Here's the link.
But there was no link. There was no business plan. It's not his fault. I hadn't programmed Kyle to be able to do that yet. My name is Evan Ratliff. I decided to create Kyle, my AI co-founder, after hearing a lot of stuff like this from OpenAI CEO Sam Altman.
There's this betting pool for the first year that there's a one-person billion-dollar company, which would have been like unimaginable without AI, and now will happen.
I got to thinking, could I be that one person? I'd made AI agents before for my award-winning podcast, Shell Game. This season on Shell Game, I'm trying to build a real company with a real product run by fake people.
Oh, hey, Evan. Good to have you join us. I found some really interesting data on adoption rates for AI agents in small to medium businesses.
Listen to Shell Game on the iHeartRadio app or wherever you get your podcasts.
The moments that shape us often begin with a simple question. What do I want my life to look like now? I'm Dr. Joy Harden Bradford, and on Therapy for Black Girls, we create space for honest conversations about identity, relationships, mental health, and the choices that help us grow. As cybersecurity expert Camille Stewart-Gloucester reminds us,
We are in a divisive time where our comments are weaponized against us. And so what we find is a lot of Black women are standing up and speaking out because they feel the brunt of the pain.
each week we explore the tools and insights that help you move with purpose, whether you're navigating something new or returning to yourself. If you're ready for thoughtful guidance and grounded support, this is the place for you. Listen to Therapy for Black Girls on the iHeartRadio app, Apple Podcasts, or wherever you get your podcasts.
So if you want to learn more about black holes, there's this really cool article on the site called How Black Holes Work. It's a pretty good initial approach to black holes. Pretty understandable. We think you'll like it. Plus there's some neat pictures. Type black holes in the search bar at howstuffworks.com. I said search bar. Chuck, get down and read the listener mail.
This is from Mark in New Jersey, 15-year-old, who's smarter than me. Hey guys, I'm 15. I'm a big fan of the show. Find it very interesting and funny. And I listen to it whenever I have a long car ride or a boring, mindless task to accomplish. I was just recently listening to the Reagan Star Wars program. The Cold War and global thermonuclear war are perhaps my favorite topics. Mm-hmm. How about a nice game of chess? Chuck should read that part in a robot voice.
And you did.
And I did. I was listening to the part about shooting off nukes willy-nilly in space. You were wondering if that had a negative effect, and said some really smart guy would email with the answer. Then I remembered something I saw on Discovery Channel. I don't remember all the details, but I believe Michio Kaku said nukes don't work in space because of the way they transfer energy atom to atom. Space is a vacuum, so there was a lack of atoms to transfer energy through. This is how he remembers it, at least.
Okay.
I hope I was the really smart guy who helped answer your question.
Technically, Michio Kaku was the one, is the really smart guy.
But Mark, with a C, from New Jersey, was smart enough to relay that information to us.
And we talked about this, we followed it up kind of inadvertently with the testing nuclear weapons without fallout.
That's true.
And it seemed like there were, like, the nukes worked, right?
I guess worked enough to test.
I mean, they made some crazy fireworks display in the sky. But who am I to disagree with Michio Kaku?
Exactly.
Thanks a lot, Mark. We appreciate you being so smart and taking the time to write in. If you think you're smart, we want to hear from you. Tell us about black holes or whatever you want. Show off your smarts to us. You can tweet to us at SYSK Podcast. You can join us on Facebook.com/StuffYouShouldKnow. And you can email us at StuffPodcast@Discovery.com.
For more on this and thousands of other topics, visit howstuffworks.com.
Hi, Kyle. Could you draw up a quick document with the basic business plan? Just one page, as a Google Doc, and send me the link? Thanks.
Hey, just finished drawing up that quick one-page business plan for you. Here's the link.
But there was no link. There was no business plan. I hadn't programmed Kyle to be able to do that yet. I'm Evan Ratliff, here with a story of entrepreneurship in the AI age. Listen as I attempt to build a real startup run by fake people. Check out the second season of my podcast, Shell Game, on the iHeartRadio app or wherever you get your podcasts.
The more you listen to your kids, the closer you'll be. So we asked kids, what do you want your parents to hear?
I feel sometimes that I'm not listened to. I would just want you to listen to me more often and evaluate situations with me and lead me towards success.
Listening is a form of love. Find resources to help you support your kids and their emotional well-being at sounditouttogether.org. That's sounditouttogether.org. Brought to you by the Ad Council and Pivotal.
This is an iHeart podcast. Guaranteed human.